So 0 is equal to L, nim sum with y, and y, so L is equal to y sub 3. So if you add, so taking back the equation that we found before and substituting that in, you get that y sub 3 is equal to s nim sum with x sub 3. So if you follow it through, the s in our example is 100 and the x sub 3 is 101. And so you get that y sub 3 is equal to 1. And basically when you plug in that equation, that's going to give you the number of sticks that you want that row to have. So if you put it back into decimal numbers, 1 is still going to be 1 in decimal numbers. So because that row had 5, you need to take 4 sticks out of row 3. So now, going back to the equation we found in the first theorem, we have that t is equal to s nim sum with x3 and y3. And using the equation that we just found on the last slide, we're going to substitute in s nim sum with x sub 3 for y3. Rearrange those, and you can see that the two s's and the two x sub 3's are also going to nim sum to 0. So you get t is equal to 0. And so basically, as long as you choose the row with the correct significant bit, you're always going to be able to find a move that that makes the nim sum 0.
So those two theorems are important because as long as you follow back and forth between those, you'll guarantee for yourself that on your last turn, once you take them all, it's only going to be one row left, meaning you take all of them or just the one that's there. And so we're going to provide like an example by going through. I'm going to be the player who knows the strategy, and Coco's just going to be making her random moves. And so here's our starting point in which the nim sum is 0.
Yeah, so we're going to follow through the same example we've been using the whole time. So let's say I take 4 out of the bottom row.
And then picking our significant bit from row 3, I'm going to remove 4 from row 3.
And then I'm going to take the rest of row 3. So I'm going to take the 1 out of row 3.
Okay. And so looking at our nim sum at the bottom right here, can anybody tell me what the most significant bit is? Yeah.
Well, couldn't you remove all of the bottom row? And then wouldn't she be, or never mind actually.
Yeah.
Remove the top row.
Yeah, that would work. And it's a bit of a trick question though, because you could actually do row 1, 2, or 3 because they all have the same 1 as the bottom nim sum does. But just because it's easier to remove the first one, we're going to go ahead and do that.
And then I'm going to take all of the sticks out of row 2.
Which leaves us with one row in which I can take all of them, leaving us with no sticks, and I win.
Yeah, so now that you know the strategy, we have a break right after this, and we have put a bunch of toothpicks on tables, so you can go play the game, try out the strategy. If you want, feel free to come challenge Audrey and I, but if the masters are too intimidating to take on, feel free to just challenge your friends and see who wins. Thank you.